Good morning, Year 11th. Hopefully you're sitting there, ready to take notes. Welcome to a very quick video and introduction to polynomials. Poly meaning many, nomial, I'm just going to say its meaning term, many terms. You will have come across polynomials before, particularly the first two. Basically, a polynomial is anything in this form. An being the first coefficient, x to the n being the power. Now, if you, vocab around this, there is x, which is the variable, a to the o, also seen as c quite often, is a constant term, meaning x is not attached to it, it stays constant throughout the entire thing. The leading coefficient is the one in front of the highest power, and it's normally non-zero. Well, it's always non-zero. The remaining coefficients can be zero, and they decrease in terms of power. And n is the degree of the polynomial for the highest power. Now, the first couple of polynomials we have named, linears and quadratics you've seen before, x and x squared. The next two are cubics and quartics, and they all have this form here. Alright, so, key points about polynomials. Two polynomials are equal, if and only equal. They have the same degree and corresponding terms of equal coefficients. So what this means is that if you have x cubed plus 3x squared plus minus 4x plus 6 equals to this, you can read off the letters. You can solve all of them by pairing them off, which is pretty neat. So that leads to problems like this one. Suppose 5x squared plus kx squared, 5x cubed rather, plus 5kx squared minus 7x minus 6 equals this for all x. Find values of a, b, c, and k. Alright, basically your plan here is to get them in general form. General form looks like this, from highest power down to lowest, listed out like that. If it's like that on both sides, it's quite easy to pick them off. So left-hand side of this is fine, we don't have to do anything to it. Ax squared minus 7x minus 6 equals. However, here we have to expand. So that 5x is going to hit everything. 5ax cubed plus 5bx squared plus 5cx. Note we put the x at the end, numbers at the first, then letters in alphabetical order in between. This 2 also hits everything. Plus 2x squared, I forgot the a, 2ax squared, plus 2bx plus 2c. Alright, and then I would equate coefficients together. Bring coefficients together. You're looking for the x squareds. And I would almost factor out those x squareds. Plus 5b plus 2ax squared. Then the x's. Five c plus 2bx plus 2c. Alright, so we're going to do the x squareds, the x's, and the constants on its own. Now, this will help us because we can probably read off a couple of the solutions. Firstly, let's look at the highest power, x cubed. 5x cubed is equal to 5ax cubed. I'm hopeful that you guys can see that tells us that a equals 1. Let's grab another one. Typically the n ones are the easiest to do. What this is saying is that 2c equals minus 6. You can treat that as exactly like an equation. You can divide both sides by 2, and therefore c is negative 3. Alright, that gives us a couple of powerful tools in terms of solving the middle ones. I would next aim for this one, 5c plus 2b, and I'd recognize that is equal to minus 7. So 5c plus 2b equals neg 7. Alright, now good news is we already know what c is. It's neg 3. This means minus 15 plus 2b equals neg 7. I would then add 15 to both sides. 2b equals 8, b equals 4. Well, that's nice. Now b equals 4, we can have an attack at a. Actually, we can have an attack at k. We're told, let's go with yellow, 2b plus 5b plus 2a equals k. 5b plus 2a equals A? Well, A is 1 and B is 5, so that's B is 4. 20 plus 2 equals K equals 22. Alright, apologies for my handwriting, but as long as you get in general form, it all sorts out relatively nicely. Alright, on with more polynomial notes. Let's introduce the concept of zeros. A zero of a polynomial is a value that you substitute in that makes it equal to 0. So, this is the fancy box from the textbook, but what you really got to notice is down here. If you have p of x is equal to this, and you sub in x equals 2, and you work it out, what you get is 0. What that means is 3 things, and they're all interchangeable. 2 is a 0 of that. Note, without the equal sign, we call it a 0. 2 is a root of this. When we make it equal to 0, sub in 2, the sides are equal, it's a root. Also, if you look at the graph y equals that cubic, it has an x-intercept of 2. Because when y is equal to 0, you get the x-intercepts. Therefore, one of the solutions is 2. Now, it tends to be that all these words are used interchangeably, even though they shouldn't be, and I am an absolute criminal in this. I will say 0 when it has an equal sign. I will say it has a root of 2 when it has no equal sign. Apologies, but here is where it should technically be used correctly. It's a 0 for an expression, a root for an equation, and it is an x-intercept for a graph. But they all mean the same thing. So here, if you sub in 2, it has a 0. And this solution, or this approach, helps us in the next section that we're going into in another video. But for now, it will let us answer this type of question. All cubic polynomials with zeros of 1, 4, and -5. Alright, so I know that if something has a 0 of 1, it will have a factor of x take 1 in it. What this means is that if I let x equal 1, x equal 4, x equal -5, the graph will hit 0, if we're thinking it as a graph. You don't have to put the y equals in front. The a in the front is to account for all the different ways we can pass through those 3 points. Because if you think about a cubic, which winds like that, it can stretch in both directions, it can stretch much further. There are lots of different ways it can go through those 3. Alright? Typically, they want the answer as in general form. So what I would do is I would expand the whole thing out and then put a into everything. Frankly, that is about as good as a solution. As you can expect, it's just fine. Alright, I think this one here is slightly more difficult, but the same process is applicable. You can either get x minus a half from there, or x minus 1. Both have the same result and are equally correct. I like 2x minus 1. Less fractions is a bit nicer. This, though, is a little nasty. You can think of this as x minus x plus 3 minus root 2 and x plus 3 plus root 2. Now that doesn't look nice at all. So typically you would at least expand and simplify the first ones. Oh, and yeah, y equals a. You would certainly expand and simplify this ugly pair here. You'll note that in the textbook it does something slightly different for this, but I quite like this setup here. So let's say y equals a bracket 2x take 1 bracket bracket. Then start foiling this out. This x hits everything. And we're going to get 9 items here, but they will work out nicely. X squared plus 3x plus x root 2. That 3 hits everything. Plus 3x plus 9 plus 3 root 2. That minus root 2 hits everything. So minus x root 2 minus 3 root 2 minus 2. Now, that, especially in my writing, looks hideous, but we should be looking for opportunities to cancel. For example, there is an x root 2 and a minus x root 2. there is a minus 3 root 2 and a 3 root 2. And what's left should tidy up relatively nicely. Y equals a bracket 2x take 1 bracket x squared plus 6x plus 7. So this quadratic here has these two roots, or two zeros, and this one comes from there, and the a gives us all the polynomials with that form. Alright, save me from writing it out, I thought I'd talk you through this one. Find the values for k which have two distinct roots, real roots, repeated root, and no real roots. Alright, start off with, we put this into general form, so we subtract 1, general form meaning just 0 on one side, everything else on the other. From here, we identify a, b, and c, put them into discriminant, get the discriminant in general form, factorize it. Now, we might not have done a lot of practice getting this from this form to here. So, what we do is we recognize that if k is minus 9 or minus 1, there'll be zeros. These indicate the zeros, remember. And then we check for what sign go in between. So I'd be substituting minus 10 into that equation, and it will come out as positive. So put a little positive sign. Substitute a value between minus 1 and minus 9 in there, and substitute, I would substitute in 0 because it's the easiest one. If you sub in 0, you get positive. What this means is that in the positive zones, you're going to get two real distinct roots. The solution will have two answers. For two real roots, all you do is add an equals in there. Because technically, if it's equal to minus 9 or minus 1, you'll get a repeated root, which counts as 2. Repeated root is equal to minus 9 or minus 1. No real roots is strictly in between those two. Alright, and that is all you really need to know. I look forward to seeing you in class.